Now let's look at example 3, and this is going to show you the difference between replacement and without replacement. And we're given a door prize drawing scenario. So it says at a school event, there are 19 students' names in a box for a door prize drawing. There are 5 fourth graders, 10 fifth graders, and 4 sixth graders. In part A, it says 2 names are drawn without replacement, meaning when the name is picked, it's not put back in the box. The students drawn are a 4th grader and then a 5th grader in that order. Find the probability of this outcome. So I want to find the probability of choosing a 4th grader first. I'll put a little 1 down here. And then choosing a 5th grader second. Our probability formula for this is the probability of getting a 4th grader times the probability of getting a 5th grader given that we already picked a 4th grader. There's our notation. If the 4th grader is the first picked, that means since there are, 5 4th graders, he has a chance of 5 out of 19 because there's 19 total in the box. Now, for the second pick, because the name is not put back in the box, we have to assume that now there are no longer 5 4th graders in the box. There are 4 4th graders. And there are still 10 5th graders, and there are still 4 6th graders. So now we have a total of 18 rather than 19 because 1 was picked. So now the probability of choosing a 5th grader, that's 10 out of 18. So when we multiply this together, this is without replacement, I'm going to take 5/19 times 10 over 18, and that's going to give me a probability of 0.1462. Now, looking at part B, this says we're working with replacement. So 2 names are drawn with replacement. Each name is put back in the box before the next draw. The students drawn are a 4th grader and then a 5th grader in that order. Find the probability of this outcome. So to start off, remember we had 5 4th graders, we had 10 5th graders, and then we have 4 6th graders. So I want to find the probability of getting a 4th grader first and then a 5th grader second. So that's the probability of getting a 4th grader times the probability of getting a 5th grader given that the 4th grader has been picked. When we pick the 4th grader, because that's the first pick, that's still going to be 5 out of 19 times. But we put that person's name back, and it goes back to the way it was. So nothing has changed as far as what is in the box. So when we find the probability of getting a 5th grader after a 4th grader has been picked, that's going to be still 10 out of 19, not 10 out of 18, because we put that 4th grader's name back in the box. These 2 events are independent because we used replacement. When we put that name back in the box, it reset it, and then it didn't change any of the probabilities. Whereas in the first part, without the replacement, it changed the probability of picking a 5th grader from 10 out of 19 to 10 out of 18 when we made that assumption that we picked a 4th grader. So because these are independent and because we put that 4th grader's name back in the box, this is actually equivalent to the probability of choosing a 5th grader given that a 4th grader is been picked, that's the same thing as saying what's the probability of getting a fifth grader, right? It's 10 out of a total of 19. I could have written this as the probability of choosing a fourth grader times the probability of choosing a fifth grader and not worrying about the conditional. Because the conditional in this case, because we're replacing the name back in the box, the conditional doesn't matter. So there is the difference between with and without replacement, and without replacement will affect the independence of the two events. So this one is without replacement, and then this one was our example with replacement.